This is number 41 on the Geometry EOC packet. I would like to take a moment to prove the Pythagorean Theorem. The Pythagorean Theorem can be proved using similar triangles. Create a right triangle, A, B, C, and use the right triangle altitude similarity theorem to prove the Pythagorean Theorem. So the first thing I want to do is draw triangle ABC. That's what I did up here in the corner. This is triangle ABC with right angle C. And I constructed the altitude CD to hypotenuse AB. According to the right triangle altitude similarity theorem, the small triangle is similar to the medium-sized triangle is similar to the larger triangle, and that's written this way, and I've untangled my triangles. Triangle ABC is the big one. Triangle ACD is the medium-sized one over here. And triangle CBD is the small one over here. The way I name them is I match up their right angle first, and then their short sides, and then the pointy side is what I like to call it. Since the triangles are similar, remember what similar means. Corresponding parts are proportional. So AB over CB in this triangle is equal to CB over DB in the smaller triangle, and AB over AC in the larger triangle is equal to AC over AD in the medium-sized triangle. So the corresponding sides are proportional. Then if I cross-multiply each one of these proportions, I get CB squared equals AB times DB. If I cross-multiply over here, I get AC squared is equal to AB times AD. If you look back up in your original triangle, CB I'm going to call leg A, leg 1 or A, and AC I'm going to call B or leg 2 of the right triangle ABC. Now remember, we're trying to prove the Pythagorean theorem, which is A squared plus B squared equals C squared. So we want to tie all this together. Now, if you take the two equations that we have right here and we add CB plus AC squared, CB squared plus AC squared, put that over here on the left side, that's going to be equal to what they're equal to added together, AB times DB plus AB times AD. Now, if you notice over here, these both have an AB in common. So go back to algebra and remember, if two things that are multiplied together have the same factor, you can factor that out. So you take out AB, and what you're left with inside the parentheses is DB plus AD. So if you look back up at your drawing, something curious happens. DB, your original large triangle, plus AD, is equal to AB, the hypotenuse of that original right triangle. So if you substitute in for DB plus AD, the AB that it's equal to back here in your original triangle, your hypotenuse, you get AB times AB, which is AB squared. This is like amazing, actually. So what you have is CB squared plus AC squared equals AB squared. Look back up here at your original triangle. CB squared plus AC squared equals AB squared. That then can be changed since AB is the hypotenuse C, and we already said that the two legs are A and B. Using substitution, we can say A squared plus B squared equals C squared. So that is the amazing proof of the Pythagorean theorem using the right triangle altitude similarity theorem Please watch that again, go back over it because it is absolutely amazing.